So the question is, what if order doesn't matter? What do I use to count? And so that situation is where we talk about combinations. And so that's section 6.5. So a combination you can really think of, so remember permutations and arrangement, a combination is essentially a subset. You just take a group, so if I'm interested in picking 5, I just pick 5. It doesn't matter which 5 that I pick, it's just a subset of 5 things from the main group. And so that could be the way you think about a combination. So you can see the notation that we use is very similar to permutations, and it's related to permutations. There's going to be fewer because we're not counting every arrangement, and so that's why that first formula holds, although the exact mechanics of it, there's more details in that. But of course, just as we had this, the permutations on our calculator, we have combinations on our calculator too. So this is not a formula you need to memorize, although if you like to work with it, that's all right. So let's jump right into an example and you'll see the difference. And again, it's important to pay attention to how these examples are different from the permutation type of examples. So this question says, students are to answer 4 out of 5 exam questions. How many ways can the questions be chosen? So as a student, how many different ways could you do this? Now, of course, if you're answering questions on a test, it doesn't matter what order you do that. The professor has no idea when they grade. All they do is grade the test, right? So order doesn't matter here. So since you're picking 4 things out of 5 total and order doesn't matter, this is just a combination of 5 taken 4 at a time. That's one way to think about it. Or in other words, it's essentially saying how many subsets of size 4 are there out of a set of size 5. So on your calculator, what you do is you type 5, and then you go to math, go to the probability menu, and you'll pick number 3 combination, and then you can type in the 4 and press enter. And this is actually a pretty small value. There's only 5. So if you think about it, it makes sense since the order doesn't matter. It's only the number of ways you can pick 4 things out of 5. You wouldn't imagine that there would be a whole lot of those, right? So again, it's important to pay attention. The difference is here, order doesn't matter. Okay, now, just as before, we might have things that mix up the rules a little bit. So this is an example of that, and I'll tell you how I knew that right off. But let's go ahead and read the problem. So it says a desk holder has 8 pens and 5 pencils. How many ways can 4 pens or 4 pencils be selected? So this or is pretty important, right? So remember, or usually means multiplication. You're doing one thing or the other. And so we want to say, okay, how many ways could I pick 4 pens? Or, and then how many ways can I pick the pencils? So it's not saying that order matters. I mean, if I just need 4 things to write with, in the end, it doesn't matter which pen got picked first, right? So when it comes to the pens, there's 8 pens I could pick from, and I'm picking 4, and order doesn't matter. So this would be a combination of 8, 4. Now for the pencils, there's 5, and I'm picking 4. And again, it's addition because I'm doing one or the other. I'm not doing both. And so let's calculate what this comes out to. Again, I can do 8, math, and then probability menu, number 3, and then type in my 4, enter, and then add, and then essentially repeat the same thing. You might want to put parentheses around it when you do it. It's not that important, but it's a good idea. Just a good habit. So I get actually a total of 75 here. So a little bit larger, but again, you're going to have something a little bit larger, especially when you're dealing with an or an and problem. So again, it's just like dealing with sets before, but now we're in a little bit of a bigger picture, and so we're able to use other techniques. So again, combinations, order doesn't matter. I want to show you one other example so you can see how this works, and then one that's a little more complex. So I would say this first example, it's kind of like the last one, and then we'll do one where it's a little different than what we've been working on so far. So in this example, we're told a manufacturer makes 5 kinds of brown chocolate candies and 3 kinds of white chocolate candies. We have a sample package, and it's got 2 kinds of brown and 2 kinds of white. How many different sample packages can be prepared? I'm keying in on one word here, and that's the and. So it says a sample package contains 2 kinds of brown and 2 kinds of white, right? So what are my steps? I can pick the brown and then pick the white. So the question is, how many ways are there to do each step? And so when I think about the brown chocolate candies, there's 5 to pick from. It doesn't matter which 2 I pick. I just need 2. They're all the same. So a combination of 5, 2. And so I multiply. Same idea, combination of 3, 2. Okay, so if you calculate this on your calculator, you should end up with a total of 30. And again, this number is a little bit smaller, but then if you look overall, we're not dealing with very large numbers anyway. And so it's that idea of order not mattering that's kind of bringing the numbers down a little bit. So you'll notice a big change from when working with permutations. So I mentioned that I had another example that I wanted to show you, and I wanted to show you something where we maybe had to think a little bit more. And so this one says a professor assigns 3 students to work on a project. The group has to have no more than 1 freshman. How many ways can the group be selected if there are 5 freshmen and 10 sophomores in the class? And so I put a hint there. It says no more than 1 is the same as 1 or 0. That hint's kind of a key to think about this whole problem. No more than 1 implies there's more than 1 possibility. In other words, no more than 1, again, 1 or 0 freshmen can be in that group. So there's 2 different possibilities that could happen, one or the other. And again, you're picking from 2 different groups, but order doesn't matter. So let's think about this. Let's think about each case. So we could have, I want to just make 2 big blanks. Who knows what we're going to do in here? We could have 1 freshman, or we could have no freshman. Right? If we have 1 freshman, now there's 3 students. So if we have 1 freshman, there's only freshmen and sophomores in the class. That would mean automatically we have 2 sophomore. So this would be and 1 freshman and 2 sophomore. If there's no freshman, it'd be no freshman and how many sophomore? 3. Sophomores would be 3. All right, so within this first step, if I'm picking this particular group, I would say, well, how many ways can I pick 1 freshman? Well, there are 5 freshmen, so this would be a combination of 5, and you're taking 1, so 1 thing. Now, this is just 5. If you're thinking, well, there's just 5 to pick from, this does actually just equal 5. And so the group and also has sophomores, and 2 of them. So this would be 10, 2. So multiplication here, and then addition. Now, no freshmen. You could say there's 1 way to pick no freshmen. You just don't pick any. You could do 5, choose 0 here. But really, in the end, it's not a consideration because you're not picking any of them. So really, we're just picking 3 sophomores. So this would be a combination of 10, 3. And so again, I want you to practice calculating this on your calculator. And so if you do calculate this, you should end up with the following. So as you saw, there was a little more thought in this one, and it was paying attention to, even though it didn't say or, that really this meant or. So it's kind of like the previous one, but a little bit more to it than that. And there's many types of problems there could be. I could never do an example of every type of problem there possibly is, but that's what you got to build up through practice, is noticing little phrases like that.